What if I told you that the planet closest to the Sun is simultaneously one of the coldest places in our entire solar system? Yeah, you heard that right. Mercury, the tiny rock that roasts at 430 degrees Celsius on one side, can plunge to negative 180 degrees Celsius on the other side. And the reason why this sounds completely insane is because of something Mercury is desperately missing, something you're breathing right now without even thinking about it. Mercury has almost no atmosphere. Almost none. Zero protection. A ghost of a shell. What it does have is something scientists call an exosphere, and calling it an atmosphere would be like calling a single raindrop an ocean. These are not the same thing, and the difference between them is literally the difference between life and an absolute scorched, frozen, airless nightmare. Here's where it gets fascinating. On Earth, our atmosphere is a thick, layered blanket roughly 10,000 kilometers deep in its extended form. It regulates temperature, carries weather, holds oxygen, blocks radiation, and keeps water liquid on the surface. Mercury's exosphere, on the other hand, is so incredibly thin that the particles floating in it almost never collide with each other. Let that sink in. The particles in Mercury's so-called atmosphere are so sparse they don't even touch. It's less like air and more like a random scattering of lonely atoms drifting in space. Now here's the controversial part that scientists debated for years. Mercury should technically be able to hold some kind of atmosphere. It has gravity, not strong gravity, only about 38% of Earth's gravity, but enough to theoretically hold some gases close to its surface. So why doesn't it? Why is this planet essentially naked in space? The answer is brutal and multi-layered. First, Mercury sits so close to the Sun that solar wind, which is a constant stream of charged particles blasting off the Sun at speeds of around 400 to 800 kilometers per second, absolutely hammers Mercury's surface. Without a strong magnetic field to fully deflect these particles, and yes, Mercury does have a weak magnetic field, roughly 1% of Earth's, the solar wind strips away gases almost as fast as they can form. Second, because Mercury is so small and its gravity is relatively weak, any gas atoms that manage to gain enough energy from solar heating simply escape into space. They reach escape velocity and vanish. Earth's stronger gravity can hold onto heavier gases. Mercury cannot. It's constantly losing what little it gains. So what exactly is in Mercury's exosphere? This is where the data gets genuinely wild. NASA's Messenger spacecraft, which orbited Mercury from 2011 to 2015, gave us the most detailed look at this planet we've ever had. Scientists discovered that Mercury's exosphere contains hydrogen, helium, oxygen, sodium, calcium, potassium, and even water vapor in trace amounts. Some of these elements are blasted directly off the surface by solar wind in a process called sputtering. Others come from micrometeorite impacts that vaporize surface rock. Some hydrogen and helium are simply captured from the solar wind itself. The sodium in Mercury's exosphere is particularly striking. It creates a faint glow visible to telescopes from Earth. Mercury literally has a glowing tail of sodium being pushed away from it by solar radiation pressure, like a comet. A planet with a comet-like tail. That is not something they taught you in school, is it? Now here is the mind-bending implication of all this. Because Mercury has no real atmosphere, there is no atmospheric pressure on its surface. None. Without pressure, water cannot exist as a liquid. It either evaporates or stays frozen. This means that even if you somehow transported water to Mercury's surface, it would immediately turn to gas or ice depending on location. No rivers, no rain, no oceans, no weather patterns, nothing. And yet, here is the plot twist that genuinely shocked researchers. In 2012, Messenger confirmed the presence of water ice inside permanently shadowed craters near Mercury's poles. Craters so deep that sunlight never reaches their floors. With no atmosphere to transfer heat, these crater floors stay at around negative 170 degrees Celsius permanently, and water ice survives there untouched. Water ice on the hottest-faced planet to the Sun. Reality is stranger than fiction, and nobody gave us the memo. The Bepi-Colombo mission, a joint project between the European Space Agency and the Japan Aerospace Exploration Agency, launched in 2018 and is currently en route to Mercury, with an expected orbital insertion in 2025. It carries instruments specifically designed to study Mercury's exosphere in unprecedented detail. Scientists hope to understand exactly how the exosphere is formed, sustained, and destroyed in real time. The data coming back over the next several years could completely rewrite our textbooks on planetary science. Here's what makes all of this so deeply important. Studying Mercury's exosphere teaches us how planets lose their atmospheres. And that knowledge directly applies to understanding what happened to Mars, which once had a thick atmosphere and liquid water, and what could eventually happen to Earth if conditions changed drastically enough. Mercury is not just a dead rock. It is a warning and a laboratory at the same time. Every planet in our solar system tells a story. Mercury's story is about survival without armor, about a world bombarded, stripped, and frozen and scorched simultaneously, holding on to the barest whisper of an exosphere like a last breath that never fully escapes. If you find the universe this fascinating, follow us right now because we go deeper every single time, and we're just getting started. So here is your question for today. If Mercury somehow gained Earth's atmosphere overnight, what do you think would be the very first thing to change on its surface? And could life ever take hold? Drop your answer below. I want to see what you think.